Powers and roots are fundamental concepts in mathematics that offer a useful shorthand for handling large numbers and simplifying complex calculations. Understanding how powers work is key to mastering a range of mathematical operations, and there are a few rules that make dealing with powers much easier. The first rule is that when multiplying two numbers with the same base, you add their powers. For example, x squared times x cubed becomes x, because you simply add the powers, 2 and 3, to get 5. Similarly, when you are dividing two numbers with the same base, you subtract the powers. So, x divided by x squared becomes x cubed, because you subtract 2 from 5. Another helpful rule is that when you raise one power to another, you multiply the powers. For instance, x squared cubed becomes x, because you multiply 2 by 3 to get 6. There are some straightforward rules for special cases, too. Anything raised to the power of 1 is simply itself. For example, x to the power of 1 is just x. Moreover, any number raised to the power of 0 is always 1. This might seem strange at first, but mathematically, it holds true regardless of the number, so x equals 1. Next, we know that 1 raised to any power is always 1. So 1, 1, or 1, is always 1, regardless of what the exponent is. When you're dealing with fractions, the power applies to both the top and the bottom of the fraction. For instance, 1 3/5 cubed equals 8/5, cubed equals 8 cubed 5 cubed equals 5 12 125 to the power of 1, or uv equals uv, where both the numerator and denominator are squared. While these are the easy rules, there are three trickier cases. The first of these is negative powers. A negative power doesn't mean the number is negative. Instead, it means you need to flip the base and make it the reciprocal. For example, 7 minus 2 equals 1 7 squared equals 1 49th, or a cubed equals 1 a cubed, or 3/5 squared equals 5/3 squared equals 5 squared 3 squared equals 25/9. It's a simple way to turn things upside down. The second tricky rule deals with fractional powers. A fractional power represents a root. For example, x to the power of 1/2 is the same as the square root of x, and x to the power of 1/3 is the cube root of x. The last tricky rule involves two-stage fractional powers, which combine both a power and a root. For example, x to the power of 3/2 means you take the square root of x, and then cube the result. Fractional powers can feel complex because they require you to first take a root, and then raise the result to a power, but once you understand the two steps, they become much easier to manage. By mastering these basic and tricky rules, you'll find that working with powers and roots becomes a more intuitive part of your mathematical toolkit.